Hi guys, welcome back to my YouTube channel. This is Irfan. In this video, I am going to deduce Bohr's postulate of angular momentum, which states that the angular momentum of an electron in a hydrogen atom is equal to the integral multiples of h bar. Alright, and h bar is equal to h upon 2 pi. So L can be written as nh upon 2 pi, where L is integer whose value is from n equal to 1, 2, 3 up to infinity. Alright, so this is the quantization principle of angular momentum, or you can also call it Bohr's quantization principle of angular momentum. This is the angular momentum of electron, and this is the value that electron can take in integer multiples of h by 2 pi. So how can we deduce this formula? Bohr himself didn't deduce this formula, and he just postulated it without any, not even mathematical proof. Alright, so it was de Broglie, right, in 1924, right. He proposed the de Broglie hypothesis, and from his hypothesis of wave nature of electron and all the other material particles, he deduced this Bohr's postulate of angular momentum. So how did he do that? Let's explore it here. So de Broglie, he said that an electron that revolves in around the nucleus, which is the positively charged particles composed of neutrons and protons, this electron actually exceed wave nature. And this wave, what kind of wave? He said that this electron exhibit a standing wave, some sort of a standing wave that is similar to the standing waves on a string when it is fixed at two endpoints. Alright, so if you have this string, so suppose this is a string and this is a wall fixed, whose two ends are fixed, then if you vibrate it, then it will form a standing wave like that. So this is just one wave, and it can form two waves, three waves, and n waves depending on the length of the string and how you vibrate it. Right, so in the same way, when electron revolves in the nucleus, it forms a standing waves, means it revolves around the nucleus in a standing wave manner. Alright, so if you have, suppose its radius is r, alright, then its circumference is equal to 2 pi r. You know from the basic theory of standing waves that to form the constructive interference, for the constructive interference to take place and to form the standing waves on a string, the length of the, if this is length, then this length should be equal to n times lambda. This is the condition for constructive interference. Alright, so if this is supposed to be the length of a string, then 2 pi r should be equal to n lambda, and here will be n also, because if you take the first radius of the electron, it means the first orbital radius, then in the first orbital radius n will take value 1, and so it will form just one wave. Right, so if you transform it into electron circular, then you can bend this wire, and so there will be one wave like this. And if you can translate into circular orbits, so you have this one wave, which is something like this. Right, so if you stretch this circular wire into this straight wire, then you will get this exact wave. So this is for n is equal to 1, and as you increase the value of n, this wave, the number of wave will increase. which you can calculate from this formula. Alright, so corresponding to the orbital radius, there is a number of waves formed by the electron, moving electron. Alright, so we have this relation. Okay, also we know that the angular momentum of electron can be written as, it is simply r cross p, and for the circular motion it is simply rp, because the value of theta is 90 degrees, so sin theta is just 1, and you can write it as mvr. Alright, now so let this be equation 1, and the de Broglie wavelength is given as h is equal to h by p. Alright, and so lambda n, nth wavelength, will be given by h upon, it can be written m v n, the velocity of electron in nth orbit, and here you can write vn rn. Right, so we have equation 2 and we have this equation 3. We can put the value of vn and rn from this equation 1 and equation 3 in this equation 2. So from there we will put the value of vn. Okay, and here we will use this relation. So look at here, we have we have m vn rn. Alright, so from this equation we have rn is equal to n lambda by 2 pi. So m, and from here vn is equal to m lambda by h. So we have, as you can see here, vn will be equal to h by m lambda, h by m lambda, and rn here n lambda by 2 pi. So we have n lambda by 2 pi. Right, so here lambda and lambda will get cancelled, m and m will get cancelled, and we will be left with nh by 2 pi. And this is exactly same what Bohr had postulated. L should be equal to nh upon 2 pi, or you can write nh bar simply. H bar is equal to h upon 2 pi. So that's how we can deduce the angular momentum, the quantization of angular momentum from the de Broglie hypothesis. Alright, so look at here that I had written lambda n is equal to h upon m v n. Okay, so you can eliminate this n. Okay, no need to write the subscript n, because if you take velocity in nth orbit, then it will give you the wavelength. Okay, so it will give you the wavelength, not the number of wavelengths, so you don't need to write this n subscript. Okay, so that's why I had used without subscript here. So I hope you understood it. So this is the first page, this is the second page. Thank you, see you later in another video.